So we're going to pick up this right where we left off on the last video. Last time we were talking about different types of angles, and this picture showed up asking how many different types of angles can you pick out of here. Just real quick, if I'm looking at it, I see some vertical angles right there. I see a linear pair 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 there. I see maybe some alternate interior angles right there. I see a right angle there. I see an obtuse angle. I see an acute angle. I don't know, we could keep going on, but idea is if you look around, angles are everywhere. That's kind of what you want to be looking at as you work on the project for this little section here over the next couple of days. Today's real topic is how many degrees are in a triangle. That's the first piece, and so you probably already know the answer, don't you? There you go. There it is. So we're just going to quick pretend, use our little protractor. We can measure some angles. So we've got, what's that, about a 50-degree angle right there. So I've got a 50-degree angle, and then if I grab the triangle and pull it over here, I've got a, what's that one going to be? That one looks like about another 50-degree angle. So I got a 50 there and a 50 there, and then I'm going to have to really do some crazy manipulation to get this thing to work the way I want it to. I think. Maybe. Maybe not. Wasn't that one of spin? There it goes, huh? Huh. No idea how to spin this thing. Anyway, we measured that one, and I would be willing to guess that would be an 80-degree angle if I measured it. Kind of just pretend it is. So an 80 degrees, and probably 180 degrees. You've probably heard that before. Mr. Bailey probably told you. Ms. Ham probably told you. Your 5th grade teacher, 6th grade teacher, Mr. Duplessis probably mentioned it. Any number of possibilities. What happened to the rest? Oh, it's that extra blank screen. So we could do that all day. We could measure every single one of these triangles. We'd probably find that there was 180 degrees in each triangle, but that's just 4 triangles. We want to get a little more sophisticated and actually prove it. So we're going to go a couple of proofs as we're working our way through here. First, we're going to do what's called a proof by transformation. Remember transformation, rotation, slides, all that kind of stuff? So remember that when we do a transformation, the angles don't change, the side lengths don't change. Basically we just get a copy of the thing. So when I do a proof by transformation, I'm going to take this triangle right here. I'm just going to line it up right there next to it so that these two make one straight solid line. I'm going to take another copy of it, and this one I'm going to have to play with a little bit. Turn it upside down. Okay. And it should squeeze right in there. Okay. And if you notice, I now have angle A, angle upside down in B, and angle C right in one line. Okay, we might call that a linear pair. That's a linear trio. They make up 180 degrees, so angle A plus angle B plus angle C for this particular triangle make 180 degrees, and that's the 3 angles that are in each triangle. So proof by transformation, 180 degrees in a triangle. Okay, it worked for that particular one. Didn't do any angle measurements. It would work no matter which triangles I picked. I could probably make that happen. You can try it at home if you like. Okay, proof with parallel lines. This one may be a little bit odd for you to deal with, but I'm going to draw a line right there. Okay? Question is, if I were to take a line, have it pass through point B, and have it be parallel to this side AC, how many different ways could I do that? You're thinking just one, probably, right? There's only one way I could draw that line, make this line parallel to that line, pass through this top of the triangle. Okay, there's a long story associated with the end of the story. Okay, so now you can stop fast forwarding. But we've got a straight line. It is parallel, this one here, is parallel to that line. Okay, that makes this a transversal. That makes this a transversal. Okay, what do we know about this angle and that angle? We know that they're alternate interior angles. We know that if they're parallel, these angles are the same. So right up there, that's angle C. These two are the same measure. Same thing here. I've got an angle A here. I've got an alternate interior angle there because of the parallel lines from the other day. So those two are the same. So again, in this straight line, I've got angle A, angle B, and angle C, and thus a triangle has 180 degrees. So all triangles have 180 degrees. Hopefully we've done more than in this case than just say it's the case. We've actually shown it to be the case for no matter what triangle I have, I can shift this triangle and get the same thing, A, B, and C in a straight line, have 180 degrees. Okay? So remember that forever and always. Okay? Now, oops, you know what I realized after the last test is the last video is that I say the word okay far too many times. So from here on in the rest of the video, I'm going to try not to say okay as I make the video, except for that one time. So please keep track from here on how many times I say that word, and I will try not to say it from the rest of the way in. So while I was just vamping there, I drew in a line, an exterior angle, an exterior line, so it comes outside of the triangle. We're going to call that angle, I'll put it in this letter, we'll call it angle D, because we've got A, B, C, and D. Okay? D is called an exterior angle. Okay? Oh, it did it. These are called remote interior angles. The reason they're called remote interior angles is because they are far away from this exterior angle. So what we want to figure out is there a relationship between angle D and the rest of these angles? So let's take a look. We just learned that there's 180 degrees in a triangle. So we know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. We know, we hope we know, that angle C and angle D are a linear pair. So angle C plus angle D should also equal 180 degrees. Seems reasonable. And remember, measure means that we're just talking about a number. Since they both equal 180, we can make them equal each other. I'll do this down here. The measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle C plus the measure of angle D. And like we did last time, there's an angle C on this side and angle C on that side. I can subtract them away. I'm just going to cancel them out and be left with the statement that the measure of angle A plus the measure of angle B is equal to the measure of angle D. So if I know these two angles, I can add them up and get that angle. If I know this angle and that angle, I can do a subtraction to get that angle. So just a little quick property as we're trying to solve some of these problems. Don't have the Bob running, so I'm just checking my time. I'm doing fine. That covers exterior angles. So the exterior angle is equal to the sum of the two remote interior angles. Just a little shortcut that you might remember. So what does this look like as we're trying to solve problems? The sort of things that you're going to be doing with this particular piece. You're going to be given problems like this, and I'll be honest with you, there's a problem that looks something like this on the final exam, so you might want to get to the place where you have it. You're going to be given some angle measurements, and you need to figure out the rest of them. So angle 2 is 80 degrees. Angle 5 is 115 degrees. Angle 10 is 90, and again, don't get caught up by it doesn't look like this, or it looks like it is this, or what have you. Angle 11 over here is 50 degrees. Angle 13 is 105 degrees. And lastly, angle 14 is equal to angle 10, so angle 14 is 90 because angle 10 is also 90. Now we set the work of trying to figure out some of these angle measurements. Okay? Where do we start? Could start over here with 90 degree with angle 1, but probably not going to get there. So let's start with someplace with blue so we can keep track of where we are. Over in this triangle, I've got two of the three angles. 90 plus 50 is 140, so that leaves me with 40 degrees for this angle. Great, we're there. So 40 degrees there. This is a nice straight line. I know because I drew it. So this is a nice straight line here. So these three angles have to add up to 180 degrees. 90 plus 40 is 130. Takes another 50 to get to there. So we're working our way through. And again, don't worry about doing it in number order. If you do that, it'll make you crazy. Angle 12 and angle 6, what kind of angles are those? They're vertical angles. So vertical angles are the same. They're equal to each other. So this is 40. See how we're working our way around this around this triangle? And now we've got a 40-degree angle here, 115-degree angle there. That'll help us get angle 3 over in this corner. So 115 plus 40 is 155. That leaves me with 25 for this angle. Let me check that. 65, 75, 80. Yep. So 25 there for that angle. Now, what are we left with? Well, could we do? Well, we know this angle right here, angle 5 is 115. So 80 plus something has to equal 115. So whatever these two add up, that exterior angle, add up to 115. So 80 plus 35. So this one's 35. And now we're left with, well, we can either go with 180 minus, well, 115. So we can do a linear pair between 4 and 5. That leaves me with, what did we just say, 65? 65 degrees there. Finally, we're down to these two angles. This angle plus that angle has to equal 105, so that's 55 degrees. And this angle plus that one has to equal 180, so that one's 75 degrees. We can check that. 50 and 55 is 105, plus 75 is 180, so we've got it. That's the sort of problem that we're gonna work our way through. Start off with a little simpler ones, but honestly, time you get to the exam, you'll see one of those. Another one, a little different setup on this one. We'll keep with the blue and we'll switch to green. So angle 1 is 2x plus 4. Angle 2 is 3x minus 5. Angle 3 is x plus 13. We also know that AB is perpendicular to BC. So that means that right here I've got a right angle. And AB is parallel to CD. So lots of information going on this particular little problem. All right, here's the thing. We know that these three angles add up to 180 degrees. So we're going to add them up. 3x minus 5 plus 2x plus 4 plus x plus 13 equals 180. Combine our like terms. I've got 2x, 3x plus 2x plus another x, so that's 6x. I've got negative 5 plus 4 is negative 1. Negative 1 plus 13 is positive 12. 6x plus 12 equals 180. Subtract 12 from both sides. I'm left with 6x equals, this is an 8, 168. And then I do the division. X equals, I think it's 6 goes into there twice. Is that right? 48, so it's 28. 6 times 28, 120 plus 48. Yep. So x is 28. Great. So that's a first step. I know that x equals 28. That'll help me figure out what all these numbers here are. This one is 28 plus 13, 48, 51. This one is 2 times 28, which is 56, plus 4, which is 60. And this one is 3 times 28, which is 60, 84, minus 5, which is 79. Check my work, because these should add up to 180 degrees, right? So this is 120. Oops, what did I do? 120, 130 plus 60 is 190. Uh-oh, somewhere we made a mistake. 28 plus 13 is actually 41, isn't it? It is. Oh, it's a eraser. It's good when we make a mistake. Really it is. Back to the pen, 41. And that's why we check our work. I didn't do that on purpose. All right, now, perpendicular, so 2 and 5 have to add up to 90. That makes that an 11-degree angle. Now, parallels. Parallels. So alternate interior angles right here. This is number 2 and number 4 are alternate interior angles, so they're the same. 79 degrees. Now I've got enough left to get this angle over here. 79, 80, 90. So I've got 90 left for that one. Okay? Oops, said it again. So that is how we're going to work this out. So you just have to work your way through. They're like little puzzles. You're given enough information to get yourself started. You know a couple of things. You know about 180 degrees in a triangle. You know about perpendiculars and parallels and all those pieces to put them together. That, I guess, does it for this particular episode, which we like to call Angles in a Triangle. So you have a few worksheets to work on this, and you should be working on your movie project, your video. You know what you're doing. Hey, thanks for watching. We'll Talk to you soon. I hope that you learned something.